Okay, so in continuation of the previous video where we were studying about the interpretation of the nuclear NMR spectra, so here we will study about the shielded or downfield or higher frequency. So shielding and deshielding, what is the meaning of that one? So for example, if you can consider this image, here you can see this nucleus is surrounded by only 2 electrons, and this side we have a nucleus surrounded by many electrons. So this nucleus is experiencing very high magnetic field, applied magnetic field, and this nucleus will be experiencing very less applied magnetic field. So nucleus, when it is surrounded by the less electron, it is called deshielded nucleus, and the nucleus which is surrounded by more electron is called shielded nucleus. Since electrons are spinning and they have a negative charge, so they create their own small magnetic field which is represented by the electron, and this small electronic magnetic field opposes the external magnetic field. Therefore, deshielded nucleus experiences more B0, which is external magnetic field, and shielded nucleus experiences less magnetic field. So we can write that B effective will be equal to B0 minus B electron. So we can summarize them like if we have less electron surrounded by electron, less electrons surround on the nucleus, then shielding goes down, and then B effective will be high, and the resonance frequency required to resonate the electron out of the nucleus will be higher. On the other hand, if the electrons are higher, then shielding goes very high around the nucleus, and B effective will be low, and the frequency will also be low. So now you can ask why B effective and frequency, what is the relationship, why it happening. So resonance frequency is that, this is the according to formula, resonance frequency data over 2 pi B0. So resonance frequency is depend on the B0, which is have a direct relationship. If B0 is high, resonance frequency will be high, and so the B effective. So we can say, now we can say that the electrons, if electrons are less around the nucleus, they are called the deshielded nucleus, and they will appear at a very high frequency. So that is why we said that high chemical shift or high frequency means higher ppm value will come. On the other hand, if we have a higher electrons surrounded on the nucleus, then the nucleus is called the shielded nucleus, and it will appear at a low frequency. Low frequency will be on the right hand side, or that is why we said low frequency or low chemical shift. So we will study about the 2 examples to understand this concept. Okay, so let's understand with the 2 examples for the shielding and deshielding in proton NMR. So here we have ethanol, 1H NMR of ethanol, CS3, CS2, OH, and this is the carbon NMR, 2 carbons are there. So if you notice this chemical structure of this ethanol, we have CS3, then CS2, and then OH. So since this oxygen is more electronegative, so what it does, it pulls the electron from these hydrogen toward itself, and because of the electronegativity, the electrons environment goes poor with these hydrogen, and also similarly for this one. So they are called deshielded protons, and this electronegativity effect is less on the CS3 protons. That is why they have comparatively electron rich environment, and they are called shielded protons. So these CS3 shielded protons appear at upfield here, and these deshielded protons appear at downfield, and the effect on the this hydrogen is sometime it changes, so which is coming here. And similarly, in case of the carbon also, so this carbon is proton is shielded, and this carbon is kind of just deshielded. On the other hand, if you notice the proton NMR and carbon NMR of ethoxybenzene, here we have oxygen, which is the electronegative, and it pulls the electron toward itself. So these hydrogens are comparatively deshielded, and they appear in the downfield, and these hydrogen, they are all in the same environment but comparatively far away from the oxygen, and they appear at upfield, right? On the other hand, this aromatic ring, if you notice that have a 3 double bond, which is the unsaturation, means it need more and more electron. So the hydrogen attached to the benzene ring, they are really in poor environment. This benzene ring sucks, all aromatic rings suck their electron from the hydrogen, and that is why they call deshielded, and they appear even further downfield or at very high frequency. So these were the examples of the shielding and deshielding of the protons, and you can understand with the other examples how which proton will appear at downfield or at higher field, and which proton will appear at the upfield or lower frequency.